the terms of a series, okay, and how to write it in sigma notation. Now we're going to look at each of our types of sequences and how we can find out what is the sum of that sequence. So you guys learned your arithmetic sequence, you've learned your quadratic sequence, and you've learned your geometric sequence. So the first thing we're going to look at is how do we sum up the terms of the arithmetic series, okay? So we could do it the long way, like what I showed you, but remember I said, what if we get to that they want the first 20 terms, okay? Or if they want the first 100 terms, they can ask you something like that. Then we can't go and sit and put each and every term number in. It's going to take too much time. So obviously in mathematics, they've derived a formula. If you're interested in the formula, it is in your textbooks. Okay, we're going to just start with the formula. It is in your formula sheet. Okay, so it's a formula that you don't need to learn off by heart, but it is good to know off by heart. So basically, if I want the sum of an arithmetic series, so the answer, okay, so for instance, in the previous, let me just find previous example, right, we did here, the sum of, that's not what I want to do. The sum of the first 7 terms gave us an answer of 119. So if I don't want to go do the step-by-step situation and I just want the answer, I can use the formula over here. So this n tells us the number of terms, obviously. The a is my first term value. Okay, and we know that d is our difference. So remember with arithmetic, it's got that constant first difference. Right? And you might recognize that this a plus n minus 1d, that is your general formula for an arithmetic sequence. So if you want to see how they got to this, the summing formula, please let me know and we can go through it together. Another interesting formula to use, or not interesting, I would say helpful formula to know, okay, is if we only get the first and last term, we can use this formula, okay? So that would be n over 2. Then you take the first plus your last, and you would get the answer, okay? So we're going to use both of these in a different number of examples, so you can get basically the hang of it, okay? So let's have a look at an example. So if I say find, so example 1, find the sum of first 20 terms. Okay, so you see there, that's going to take us a long time if we did it the long way, of the series -1 plus 3 plus 7. Okay, so they want the final answer if we had to add 20 terms of that series. Okay, so let's see. If I have my formula, Sn is equal to n over 2 2a plus n minus 1d. Okay, what do I need essentially? Okay, I know my number of terms is going to be 20. They're asking for the first 20 terms. My first term is a, right? And that is -1. My difference, okay, so if I had to do the difference between 3 and -1, I would have to add 4 to get to 3. From 3 to 7, we would have to add 4 as well. So I know my d is 4. Okay, so let's put that into our formula. So I want s of the first 20 terms. Okay, sum of the first 20 terms. My n is 20. 2 times -1, so my first term, plus 20 minus 1 times 4. Okay, and I would put that into my calculator. So as soon as you put that into your calculator, you would get 740. That is the answer if I took -1 plus 3 plus 7 plus 11. So as you go on adding those terms together, this would be your final answer if you had to add all of them together. Okay, let's look at one where only the first and the last term are given. Okay, so for instance, let's look here. Find, so this is example 2. Find the sum of the first 20 terms of the series -1 plus 3 plus 7. Ah, now I'm doing the same thing. Hold on. That is the same example. Let me redo that. Calculate the sum of the following series. I take 3 plus 5 plus 7 all the way up to 111. Okay, so here, let's have a look. All right, if I had to do Sn equals n over 2, and now I've been given the first and the last of my sequence. Okay, so I can use the a plus l. Let me see what do I need. Okay, I need the number of terms. So I see here I don't have that. Okay, I don't know what 111 is. I don't know what that is up to. So my first step is first going to find the general formula to find out what term gives me 111. So if I use the general formula, a plus n minus 1 times d, my first term is a. Okay, I want to find out what 111 is. Okay, what am I doing? The term number that will give me 111. Okay, times the difference. So from 3 to 5, that's 2. From 5 to 7, that's 2. So I know my difference is 2. So that is 2n minus 2. Okay, that is 2n. And if I take those two over, then that's 110. And that would give me 55. So I know that this is the 55th term. Okay, so now let me have a look. I'm going to do it in a different color so you can tell the difference. I know it's going to be from S, the sum of the first 55 terms. Okay, so n is 55, a is 3 plus 111. So again, we're using this formula because I've got the first and the last term. Okay, if I work that out on my calculator, I'm going to get 3,135. That is my answer. If I took from term 1 to term 55 and I added them all together, I would get 3,135. Okay, let's see what happens if they give it to us in sigma notation. Okay, so they could give us the thing in the question in sigma notation like this. So they want the sum of terms starting at term 2, ending at term 100 of the formula 7 minus 2m. And they say calculate. So they want that sum, that answer, if they took from term 2, okay, to term 100 of that formula and added it all together, what would that end result be, right? So you would go, okay, how many terms do I have there, right? How many terms do I have there? I go number of terms is equal to top minus the bottom plus 1. Okay, so that would give me 99 terms. Okay, so now if I use my formula, Sn is equal to n over 2, 2a plus n minus 1 d. Okay, my n would be 99 terms. My a, okay, is my first term. So if I go 7 minus 2 times, and remember we're starting the series at 2, so we have to put 2 there. So 7 minus 4 is going to give me 3. So a is 3 plus n is 99 minus 1 times my difference. Where can I find my difference? Okay, you should know with your formula that it's in front of your constant. That's negative 2. All right, and I'd work it out and I'd get negative 9,405. Okay, and now you're probably saying, well, we can find the last term as well. We can find the first and we can find the last one and use the other formula. That's right. Right, if I go Sn is equal to n over 2 times a plus l, my first term we worked out is 3. What about my last term? My last term would be 7 minus 2 times the last term I know is term 100. Okay, and that would give me negative 193. So in this formula, I would go, I know at this point that it is 99 terms. So my n would be 99. Okay, my first term is 3. My last term is negative 193. And you would get the same answer. So you can choose what works for you. Sometimes they won't give you that last term. So you can't use that second formula. Okay, so let's see if they ask us maybe for the number of terms. Okay, so they give us, like I said in the beginning, you can pause as you go if there's something you need to take down. So now they ask you, determine n using appropriate formula if, so that appropriate formula thing is just that you don't guess. If we've got sigma notation, let me leave space, sigma notation for n r equals to 1. So we're starting at 1. We're not sure what our last term will be. That's what we're working out for this arithmetic sequence right here. And they say that the answer, if we had to add up those terms, would give us an answer of 456, right? So let's see. If we've got Sn is equal to n over 2, 2a plus n minus 1 d. Okay, we know the sum of those terms will give us 456. So we know that the whole thing will equal to 456. N is what we're looking for. Okay, 2 times my first term. My first term would be if I started at 1. So r is equal to 1. And that would give me 5. So that's my first term. I'm looking for my n. Sorry. Okay, and my difference, where would I find it? Over there. Okay, we know that it's in front of my variable, so it will be 6. Because if you expanded this, right, if they say expand this, your first term, you would say, okay, it starts at 1 because it told us it starts at 1 is 5. Then it would be 2, right? So that would be 12 minus 1 is 11. Then 3 is 16. So this sequence would look like this: 5, 11, and 16. And we are just trying to find out if we added those terms together up until term n, what that would give us 456. So until what term that is. So we have to do this algebraically. So we say 456. Let's simplify the brackets. 456 equals n over 2. This is 10 plus 6n minus 6, right? Okay, this whole thing is divide by 2, so we need to times by 2. So if I go 456 times 2, I get 912 equals n times 10 minus 6 is 4 plus 6n. Okay, this would now give me 912 is equal to 4n plus 6n squared. So I hope that you're starting to see this as a trinomial. So 6n squared plus 4n minus 912. Okay. Then if I look here, I can divide everything by 2. So that would give me 0 is equal to 3n squared plus 2n minus 456. If I look at that with my trinomial, this would be n minus 12, 3n plus 38. If you're confused how I did that, then we need to go back to advanced trinomials. So that means my term is equal to 12, or my term is equal to negative 38. Okay, and like we know that term numbers cannot be negative, we will say that term, if I take the sum of the first 12 terms, that's going to give me 456. Okay, I hope this video helped. There's many YouTube videos on this, so if there's any confusion, then you can go watch those as well. Otherwise, just then pop me a message.